you can look at percent increase in days exceeding a temperature threshold. So we found temperature thresholds in the literature for mountain pine beetle, and particularly winter temperatures are critical for how many instars or reproductive cycles some of these mountain pine beetles can have. And we just looked at percent increase in these temperature thresholds from the literature. And you can see that by the end of the century for the RCP 8.5, we might expect a 3% increase in days exceeding a temperature threshold for the survival of these beetles. And this is a risk of pathogens and insect disturbance moving forward. So a lot of these forests, especially in the northwestern part of the state that weren't severely impacted by beetles or defoliators during this last outbreak, might be vulnerable moving forward, especially if climate continues on its current trajectory. Okay, and lastly, I wanted to leave you with this recent study from Abigail Swan at University of Washington, and she looked at this commonly used drought index called the Palmer Drought Severity Index, and what it shows for moving forward for future climate projections. And then she looked at this difference in precipitation minus evapotranspiration, so this more ecosystem meaningful drought metric. And what she found was that when you looked at just the radiative impacts of CO2, so just the climate impacts of CO2, what you found was pretty severe drought, both in both of these indices, the Palmer Drought Severity Index and the looking at precipitation minus evapotranspiration. But then when you considered the physiological effects of CO2, CO2 could ameliorate some of these drought impacts for certain regions. And this was a global study, but what really struck me was that Montana is in this really pivotal spot. So any place that's brown for this full suite of factors, so the physiological effects and the radiative effects of CO2, any place that's brown, we would expect that evapotranspiration will exceed precipitation and we'll see widespread drought. So Southwest sees widespread drought, that precipitation will not increase enough to exceed the increase in evapotranspiration. However, as you move into the Pacific Northwest, precipitation increases faster than evapotranspiration, so you get a positive water balance. But you can see that Montana's in this really pivotal spot where, western Montana could see increased water balance, whereas eastern Montana could see a negative water balance. So it's really critical looking forward at some of these metrics and how they respond. Okay, and another thing that we learned during this process in talking to people about forest impacts was that there are a lot of potential impacts to the livelihoods of Montanans. And, historically, Montana has been an extractive state where the economy's relied on extracting resources. And, some of these resources are no longer extracted, but we still rely on forest resources. And there's been, a little resurgence in using wood for things like cross-laminated timber. So, these are resources that we rely on, and uh, we really need to manage them in the context of this changing climate. So that was one region that one potential impact where we think that these climate impacts are going to have real um, they're going to be felt by the citizens of Montana. Also, in speaking with folks at Salish Kootenai Tribal Forestry, we learned that there are a lot of species associated with forests or woodland openings in woodlands around forests that are important cultural species, such as purple coneflower, chokecherry, red raspberry, huckleberries that we all know and love, and some of these other species that have been historically important species that have been harvested by tribes. So there's a lot of potential repercussions, both economic and cultural repercussions for changes in forest distributions in response to climate. And lastly, I want to leave you with this parting shot, which really illustrates how forests have changed outside of Missoula. So here's a historic view of Mount Sentinel, and what's immediately evident when you look at Mount Sentinel is that you tend to find forests growing on the northeastern slopes and grasslands growing on the western southern slopes of Mount Sentinel, largely governed by the local water balance. So in these hollows, you have water for trees to grow, whereas these grasslands get really baked, especially in the summertime. So trees can't grow. So just looking at this historical photo of Mount Sentinel at the turn of the 20th century, we see a lot of forest on the north slope, but not much forest on the western slope. And then if we look at a modern image of Mount Sentinel, essentially the same view, you can see that forests have creeped down into the hollows of Mount Sentinel and into these ravines, but it's much barer over here on the northern flank of Mount Sentinel. And it's clear that forests are dynamic and they've changed over time. So clearly, forests have become more abundant in these hollows. Just wanted to point out with these images is that forests have responded historically to changes in climate and land use, and they've responded in dynamic ways. And in some areas, forests have crept down the slope of Mount Sentinel, and other areas the forests have thinned out. And in these gullies, forests are probably responding to increased water availability and possibly CO2. Whereas on the backside of Mount Sentinel, there was a recent fire that decimated a lot of this forest here. So moving forward, these are competing effects that will obviously influence the distribution and well-being of forests in Montana. And lastly, there's some recommended further reading. In putting together this forest impacts chapter, we came across a lot of other colleagues that were working on similar endeavors. In particular, there's this great report by Vose and Clark et al., effects of drought on forests and rangelands in the United States. So that's a continental-wide report. And then Bob Keene has been working on a report for the Northern Rockies, looking at Region 1. And then some other reports by Vose that we really relied on heavily for this chapter. And then in looking at forest mortality and climate change, there's a lot of work that's been done by Van Metegen, John Abatzoglu, And Park Williams just recently published a paper on forest fire in the West. It was a really great paper. And there's a lot of information that we're only mentioning a few studies, but there's an extensive literature that we've compiled in the chapter on forest impacts that could be of use to you in guiding your further reading. Okay,
Hey,
and that's all
Ashley.
I got.
Hey, Ash, this is
Yeah.
Anna. I just saw a question come up from Jane Mangold. She wants to know where the those publication, where is that published?
So it's a report, and it is I think it was a U.S. Forest Service report or a USGS report, Effects of Drought on Forests and Rangelands in the United States, a comprehensive science synthesis. But I think Vose won an award for that particular report. It's very extensive and pretty well done.
Great. Well, Ash, thank you so much. That was great. And even though we lost you, it was only for a couple minutes.
Yeah,
If anyone
thanks
else
for
has
having me.
questions, feel free to type them
Okay.
in. The area to type in questions is kind of the bottom of your screen where it says got questions, ask them here. I would also like to remind everyone that over on the far right in the middle of the screen, it says helpful websites. And those are wonderful websites that you can find quite a bit of information about climate in Montana, work being done at the universities. Also, if you go halfway down, there's something that says session 4 evaluation. We would love it if you could complete an evaluation. Doesn't take very long. And that is about it for me. Ashley, do you have anything else?
So one website that isn't up there, helpful websites, is of course the Intergovernmental Panel on Climate Change. And um, in thinking about the impacts of climate on terrestrial ecosystems in general, there's a great chapter by Philippe Sier, who I'm currently working with on the uncertainties of terrestrial ecosystems and terrestrial ecosystem processes in climate change. So there's a lot of great information there too.
Great. And it looks like Jane found that article, Forest Service. She put the link down at the bottom. Anyone else who might be interested?
Okay.
Thanks, Jane.
Excellent. And the other thing in terms of my research, there's a lot of interest in the climate carbon interactions. As you can tell from this webinar based on Montana, there's a lot of uncertainty. And currently, half of the CO2 that we emit into the atmosphere is taken up by plants on land or by ocean processes. And we really don't know how long those so-called carbon sinks will persist moving forward, and what the impacts of that carbon uptake are. So it turns out that it's a rather large uncertainty for future climate projections. So the carbon cycle is this big unknown, and we're really trying to improve the models of carbon cycle processes so that we can reduce some of those uncertainties on future climate projections.
Well, it doesn't look like we have any more questions. So I think that this completes our month-long webinar series. So thanks again to all of you who participated.